Soil sampling is important to making effective farm management and soil fertility decisions. It is the process of collecting soil samples from the field destined for analysis in the lab.
For us to make a recommendation for fertilizers in the field for the different crops, that we need to bring some of that samples of the soil that the crops are growing on into the lab to do the test. Of course, we only need a very small portion of the soils in the field to do that analysis, probably around 1 pound.
It is advisable to do soil sampling before planting. However, if crops are showing symptoms of deficiencies, samples can be taken to the lab for testing and recommendations. For effective results, avoid taking samples during periods that are either too wet or too dry. Samples should not be taken from waterlogged land, sections used to store fertilizer, manure, and rubbish heaps, freshly dug ditches, and fence lines.
A crop would need the essential nutrients to give you a healthy and productive crop. Some of those nutrients come in the form of elements such as calcium, magnesium, sodium, potassium, iron, copper, manganese, zinc. And we also do other tests to look at toxicities that occur within the soils, such testing of things like salts. Is the soil saline? Is the pH right and ready to support crop growth?
The frequency of sampling is determined by the crop being cultivated in the field.
You can sample, especially those long-term crops that are going to be in the field for most of the year, or permanently in the field, like the perennial crops, the fruit trees and what have you. You can afford to do your sampling maybe once every 2 to 3 years. But for those crops that are making constant demand, like your cash crops, where every 6 weeks or so you're harvesting your tomatoes, you're harvesting your celery, you're harvesting your cauliflower, it is making a constant demand on the soil. And so you need to be monitoring very closely how the nutrients are varying in that soil. And so your frequency of sampling would have to be a bit more than for those permanent crops. Because they are very shallow feeders, meaning they do not go, their roots do not go very deep into the soil, then you try to capture what is the state, the chemical state of the soil within the first 6 inches or first 15 centimeters of that soil. And also what happens below that first 15 centimeters, going all the way down to 30 centimeters or 12 inches below the soil. For other crops that are more deep-rooted, more like the prominent crops, you tend to go a bit deeper. And you go as deep as 2 feet or 60 centimeters.
When taking the soil sample, the shape or evenness of the landscape is important.
The land that you're going to. Is it even? Is it flat? Is it sloping? Because those would have implications for the availability of nutrients and how you treat where you collect the samples. You try to collect from every variation in the field, and when we go to the field, you see that. Wherever there are sloping areas, you have to collect samples to represent those sloping areas. Where there are flat areas, you have to collect samples to represent those flat areas. And to do that, you need to work with the appropriate tools.
Tools needed to take a soil sample are a bucket, cutlass, soil auger, soil probe, shovel, permanent marker, pen, a notebook, bags, and a ruler.
So once you've identified your sections in the field, for each of those sections, like I said, in the sloping areas, you try to collect at least five samples. From your flat areas, you try to also collect at least 5 samples. And when you collect those samples in the field from 5 different points, the plan is to make a composite of those 5 different samples that you have collected from the one particular area. How do you make a composite? We can have a practical demonstration of that, but you have your bucket. And if you are deciding to collect samples for a cash crop and you're looking at the first 15 centimeters or 6 inches of the soil and the second 15 centimeters or within the first 30 centimeters of the soil, then you need to separate all of your topsoil into a bucket, and then you do a mixing to make a composite. And out of that composite, you will take approximately 1 pound to be sent to the lab for analysis.
The samples being sent to the lab should be properly labeled with the name of the farmer, location, depth of soil, and history of the field. This is where the pen and notebook plays an important part.
So as you can see, we're now in the sample collection room, and it's also storage room. You can see we have samples that are sitting here that came in for analysis probably within the last 10 years. And so if you had a sample done and you need to have some traceability as to how that land is progressing, you can always go back to the old sample and do additional analysis and compare it with the current samples that you're collecting. So we have a sample collection room, and every sample has a code, and this is where traceability is important. So we can go back and say who it came from, and we have the results to go with the sample. But when the sample comes into us, it comes into this in this form. You can see it's wet. Most times it's clumpy. It has some identification mark on it as to who it came from, where it came from, when it came. And then we would then put it out, try to get it into some small pieces so it dries very quickly, and allow it to air dry. And having air dried, then you crush it to get it to almost very small, tiny particle size. And so you see you're moving from very large particle size to medium particle size to very small, fine particle size. And the idea here is, because the smaller the particle size that you have more surface area in your soil for which you to extract the nutrients. And so when you extract the nutrients, you have a very good correlation as to how much nutrients are contained in that soil that is now available to the plant. Because this is where the plant goes to get its food, from the small particles, okay, as opposed to these big clumps. So we have that, and then you're ready to do the analysis in the lab using the different extraction solutions. Elements in the soil, it gets it into very small atomic state, and then it's detectable electronically on these atomic absorption spectrophotometer. And so you're able to determine your elements like your calcium, your magnesium, your sodium, your potassium, your iron, copper, manganese, and zinc. Those elements are able to determine on these instruments, and it will then be able to tell you whether or not you have adequate amounts within the soil.